We've come a long way from the hulking mainframe computers of yesteryear. Computers that once filled buildings are now small enough to fit on a fingertip. Even though they've gotten smaller and faster, our need for compute power continues to grow. How is the Biocomplexity Institute preparing to shape the future of high-performance computing?
This is the new Biocomplexity Institute's data center. Basically, we had to build a new data center because we're out of space and cooling in our present facilities. For meeting our future needs, we need to be able to handle a large amount of power and a large amount of cooling. So we ended up deploying chilled water doors. And so this new facility can handle up to 2 megawatts of power. And so we're looking at about 1,800 kW in the data center itself, plus we have UPS units as well.
Overheating in large data centers is a constant problem. The chilled water doors work much like a car radiator, pulling off the heat generated by the computers and cooling the air so the clusters don't overheat.
This makes it more cost efficient, much higher energy density in these racks. So if we went with traditional air-cooled, we wouldn't be able to fit all the compute power we want in this room.
The Biocomplexity Institute needs all this compute power because it's an integral part of finding the answers to massive problems our researchers are tasked with solving, such as the Ebola epidemic in West Africa in 2014, which highlighted how essential HPC data centers are to combating disease.
They had to have information about where people were moving around in the country, how they traveled, what the road conditions were, where the virus was spreading. So these were key factors that they had to look at for doing their modeling. So having good compute power really helps benefit. Having these sort of capabilities can help for decision makers really to make good decisions on how to handle problems.
With the new chilled water system and an equipment donation from NASA Goddard Space Flight Center, the Biocomplexity Institute's third data center is up and running.
The NASA system essentially doubles our compute power here at the Biocomplexity Institute,
which gives the Institute the capability to achieve new goals.
We have a large range of science goals that we're trying to accomplish. We're modeling human populations, we're doing genomics research, we're just doing modeling of the whole human systems from the molecular scale up to planetary scale. So we need a lot of compute resources to be able to do this work. So the NASA donation allows us to have additional resources. So it gives us the capability to have people run at very large scale on different clusters.
We're already reaching new frontiers of research just in the 6 months since the data center became operational.
Recently, we were awarded an award from Defense University Research Instrumentation Program. We submitted a proposal to build a large shared memory system. The reason why they need something like this is to really look at how people travel. So you need to be able to do this in a very large memory environment. So the system we're getting is going to have about 15 terabytes of memory in a single system image. That means that it's one OS, so we can have jobs that are running. They can talk to the same memory without having to go out and talk to another machine. So it really helps in these very complex interconnected problems such as air travel and other things like that.